In problem example 8, I should say, we want to summarize our dilations and look what's happening here. Notice on the first g of x, I'm multiplying in my exponent. In my exponent, that's going to be horizontal. If it will right there. Now, what am I doing? Well, I'm multiplying by 2/3, but since it's horizontal, I'm actually dividing by 2/3. Dividing by 2/3 is the same thing as multiplying by 3/2. So that's a stretch by a factor of 2/3. Now, in h of x, I'm multiplying by 3, aren't I, to my exponent. So when you multiply by 3, that's a vertical. And since it's bigger than 1, it's a stretch. And then I'm doing it by a factor of 3. On the next one, it's 6/7. I'm multiplying by 6/7. And that's not in the exponent, so that's vertical. But this time, it's a compression, isn't it? Because it's less than 1. So we're going to say a vertical compression. So I'm going to multiply each y by 6/7. Finally, I'm in the exponent again, so I know it's horizontal. And since I'm dividing by 5/2, that's the same thing as multiplying by 2/5. So multiplying by 2/5 would be a compression. I'm going to take each x value, I'm going to multiply it by 2/5, which, oh, there we go, 2/5. Now in example 9, I want to write the equation of my parent function, and my parent function is f of x. So if I look at f of x, notice it's not horizontal because my y-intercept changes. If my y-intercept doesn't change, it's horizontal. So then I look at what is going on here, and I can see it's going to be a compression. What's my compression? That's really what I'm thinking of. So if I think here, it's going to be f of x equals a times 2 to the x power. Well, let's pick a value I know. I like this point right here on g of x. So on g of x, I probably should have said g of x equals a times 2 to the x. My ordered pair is 2 and 1. So in other words, 1 is my y value, and 2 is my x value. So 2 to the second. So that'll help me find a. So in other words, a equals, or 1 equals 4a. So we divide by 4. A is 1/4. So in other words, I'm going to say g of x, let's write it over here, equals 1/4 times 2 to the x power. There is my equation of g to x. Could I have found that a different way? Sure, I could have. Notice my corresponding value in f of x is up here. So I look at 1, and this point is at 2 and 1, 2, 3, 4. So I'd still get 1/4. You don't necessarily have to do an equation each time, but if you have a hard time finding them, I would use the equation. Now, if you multiply by -1 to your function, that is, I put a negative in front of my function, it's going to take each y value and you're going to make it opposite. So now, in other words, I'm going to flip over the x-axis. So I want to describe how g of x is related to the parent function of 2 to the x. Now we have two things going on here. We have our negative and we have our 3. So I'm going to say the order you write them doesn't matter, but my negative flips over the x-axis. I guess we're going to do be mathy. We should say it's a reflection over the x-axis. And since I'm multiplying by 3, that's a vertical stretch by a factor of 3. And there we have that one. Woo. I think we're done with this page. Yes, we are. We'll do the horizontals on the next video.